Imagine spending $60 million on a machine, and using it exactly once. That was essentially the economics of the rocket business. Then, in 2017, SpaceX did something that looked almost insane. It launched a rocket, delivered its payload, landed the most expensive part back on Earth, and then flew that same rocket again. That wasn't just an engineering achievement. It was the moment the economics of an entire industry began to change. Because SpaceX had discovered something far more valuable than a cheaper rocket. It had discovered how to turn a rocket from a disposable product into a reusable business asset. And once you understand what happened next, you'll understand why some of the biggest names in aerospace suddenly found themselves competing under a completely different set of rules. For decades, the traditional rocket business operated around one simple assumption. Build a rocket. Launch it. Lose it. Build another one. Think about how strange that sounds in almost any other industry. Airlines don't build a new airplane every time they fly from New York to Los Angeles. Shipping companies don't throw away a cargo ship after one trip. And logistics companies don't manufacture a new truck every time they deliver a package. But rockets were different. The machines were incredibly expensive, extremely complex, and historically designed to be expendable. That meant every new launch required another enormous manufacturing effort. More rockets meant more factories. More factories meant more capital. And more capital meant higher launch prices. The result was an industry where scarcity was effectively built into the business model. Then SpaceX entered the market with a completely different question. What if the rocket wasn't the product? What if the rocket was the infrastructure? SpaceX's Falcon 9 wasn't the first rocket anyone had ever attempted to recover. But the company kept pushing towards something much more important than simply landing a booster. It wanted to make reusability operational. In December 2015, Falcon 9 successfully landed after launch. But the real economic breakthrough came later. On March 30, 2017, SpaceX launched the SES-10 satellite using a Falcon 9 first-stage booster that had already flown before. The rocket went up, delivered its payload, returned to Earth. And SpaceX used the same booster again. For the first time, an orbital-class rocket had effectively become a reusable transportation asset. And that's the distinction most people miss. Landing a rocket is engineering. Flying the same rocket again is economics. Because suddenly, the question wasn't simply, how much does it cost to build a rocket? The question became, how many revenue-generating missions can one rocket perform? That's a completely different business model. Imagine two companies competing for the same customer. Company A builds a brand new rocket for every launch. Company B builds a rocket, recovers it, refurbishes it, and uses it again. Even if Company B has to spend money on inspections, maintenance, and refurbishment, the economics can change dramatically when the cost of manufacturing that expensive hardware is spread across multiple missions. And this is essentially the same principle that transformed commercial aviation. A commercial aircraft is expensive. But airlines don't need to manufacture a new aircraft after every flight. The aircraft generates value again and again. SpaceX was trying to bring that same economic logic to rockets. And that was a much bigger threat to the traditional aerospace industry than simply building a better engine. Because SpaceX wasn't just competing on technology. It was attacking the cost structure. And cost structure is where industries become vulnerable. The established aerospace companies had spent decades building around a different environment. Companies like Boeing, Lockheed Martin, and Arianespace had enormous engineering capabilities, government relationships, infrastructure, and experience. Their systems were designed around reliability, complex procurement processes, and extremely demanding missions. That model made sense. Until someone changed the economics. And that's exactly what SpaceX was trying to do. Because if your competitor builds a rocket that's 20% better, you can try to build one that's 20% better too. But what happens when your competitor changes the economics of the entire category? That's much harder to defend against. The pressure became especially significant for United Launch Alliance, the Boeing and Lockheed Martin joint venture that had dominated many U.S. government launch missions. For years, expensive launches were simply part of the reality of spaceflight. Then SpaceX began demonstrating that launch services could be offered under a fundamentally different cost structure. And suddenly, the question wasn't, why are rockets so expensive? The question became, why do they have to be? But reusability wasn't actually SpaceX's entire advantage. It was the foundation for something much bigger. Think about the flywheel. Reuse creates the possibility of more launches. More launches create more operational experience. More launches generate more data. More data helps engineers improve hardware and procedures. Better operations can increase reliability and reduce costs. Lower costs can create more demand. And more demand creates more launches. Then the cycle starts again. Reuse. Frequency. Data. Efficiency. Demand. More reuse. That's a business flywheel. And SpaceX became exceptionally good at spinning it. The Falcon program eventually moved from proving that reuse was possible to making reuse a normal part of launch operations. By 2025, SpaceX reported that Falcon first-stage boosters had been reflown more than 384 times. At that point, reusable rockets were no longer a futuristic concept. They had become an industrial operating model. And that leads to another advantage that is easy to underestimate. Frequency. A traditional rocket company could think in terms of building the next rocket. SpaceX increasingly had the ability to think in terms of launching the next mission. That difference is enormous. Because in capital-intensive industries, asset utilization matters. A factory that operates once a month is different from a factory operating every day. A truck making one delivery per week is different from a truck making 10 deliveries per day. And a rocket that flies once is fundamentally different from a rocket that can fly repeatedly. This means reusability isn't simply about reducing manufacturing costs. It's about improving capital efficiency. The same physical asset can generate revenue multiple times. And once you start looking at rockets this way, the entire industry begins to look different. But then SpaceX created something even more powerful. It created its own demand. Starlink. Instead of depending entirely on external customers to decide how many satellites needed to be launched, SpaceX could use its own rockets to build an entirely different business. And that changed the equation. The rocket business wasn't operating in isolation anymore. The launch infrastructure supported the satellite business. The satellite business created enormous demand for launches. More launches increased rocket utilization. Higher utilization created more operational experience. And more operational experience strengthened the launch system. This is what makes SpaceX's competitive position so difficult to replicate. Competitors aren't simply trying to build a reusable rocket. They're competing against an integrated system. Manufacturing. Launch infrastructure. Reusable boosters. High launch cadence. Satellite production. And a massive internal customer. That's a much bigger moat than a single piece of technology. But here's where we need to be precise. SpaceX did not literally make Boeing, Lockheed Martin, or every traditional aerospace company obsolete overnight. That's the dramatic headline. The reality is more interesting. Old aerospace companies still possess enormous advantages. Government contracts. Defense expertise. Deep engineering talent. Infrastructure. Long-standing relationships. And decades of experience operating some of the most complicated machines ever built. SpaceX didn't erase those advantages. It changed the benchmark. Suddenly, the industry had a company proving that rockets could be treated less like disposable missiles and more like reusable transportation assets. And once the benchmark changed, everyone else had to respond. That's the real story. Because the biggest lesson from SpaceX isn't actually about rockets. It's about business. The companies that dominate an industry are often built around the assumptions of the previous era. And sometimes, the most dangerous competitor isn't the company that builds a better product. It's the company that asks, why does this product have to work this way at all? SpaceX looked at a rocket and saw an aircraft. It looked at a launch and saw a recurring operation. It looked at billions of dollars of hardware and asked, why throw it away? That question helped transform the economics of spaceflight. The 2017 Falcon 9 ref flight wasn't simply the story of a rocket landing for a second time. It represented a much bigger shift. The rocket stopped being just a one-time expense. It became an asset. And once a rocket could become an asset that generates value repeatedly, the entire industry had to rethink what a launch should cost, how often rockets should fly, and ultimately what a rocket was actually worth. Because SpaceX didn't just build a reusable rocket. It helped turn reusability into a business model. And that may have been the real innovation.